you should mute. What's the name? Her name? I forgot this student name. I could. Okay. Her name is Amir Ahmad. Okay, Muhammad. You should mute your microphone, Amir Muhammad. Okay, this naming. I. This microphone is on. Sound come from here. Okay, this class. What is this? From beginning. Okay, welcome to my class, chemistry class. This is chapter 9, energy change, reversible reaction. This writing spelling wrong, reaction, and shifting the equilibrium. Energy change finished. Now I shifted to reversible reaction. Look, this is a reaction. This is hydrated copper sulfate. Because it contained water content. Look, this is water. 5 mol water contain this copper sulfate. So this is hydrated copper sulfate. Okay, hydrated copper sulfate. It because it contain 5 mol water. Okay, this is anhydrous copper sulfate. There is no water. Anhydrous copper sulfate. Okay, this is hydrated copper sulfate. Color is blue crystal. Hydrated copper sulfate, and anhydrous copper sulfate color is white color. When heat is absorbed from the system, that means endothermic reaction, blue crystal turn into white. Okay, when heat released, white crystal become blue. So when heat absorbed, blue crystal become white. When heat released, white crystal become blue. So this is when heat absorbed. This is endothermic reaction. When endothermic reaction, hydrated copper sulfate become copper sulfate. When heat release, it become exothermic reaction. Anhydrous copper sulfate become copper sulfate. So here this is the forward reaction. When reactant to product is formed, this reaction is called forward reaction. When product to reactant is formed, this is called backward reaction. When the rate of forward reaction and backward reaction is equal, it's called equilibrium, and it's shown by a sign, equilibrium symbol. This is equilibrium, half arrow. This is backward reaction, half arrow. This is the half arrow, backward reaction. So what is reversible reaction? When reactant, we know this is left hand side substance which participate in the reaction, they are reactants, and this is our product, substance which are produced in the reaction, they are product. Okay, when reactant form product and then the product react to form reactant, this is called reversible reaction. In a reversible reaction, reactant form product and then product form reactant again. This is the reversible reaction. Here reactant form product and product form again reactant. So this is a reversible reaction. Previously I showed us hydrated copper sulfate. When hydrated copper sulfate heat applied, it form anhydrous copper sulfate. When heat leaving, it become hatting. Okay, heat gaining, heat releasing. So it becomes so this reaction. In this reaction here, what happened? I have shown this ammonium chloride. When heat applied, it form ammonia gas and hydrogen chloride. When heat applied, it form ammonia gas and hydrogen. Again this is again from ammonium chloride, because here heat resist. When heat absorbed, here is the temperature. So when move to the top or higher level, it become heat lose, there is no heat, become it again turn into ammonium chloride. Here ammonium chloride, when it absorb heat, it become ammonia and hydrogen chloride. In the top, when increases, it become again ammonium chloride, because there is no heat. So reversible reaction occur. Okay. Again this is ammonia from ammonium chloride from ammonia and hydrogen, again ammonia and hydrogen chloride gas from ammonium chloride. These things previous session, this is when ammonium chloride heated, it from ammonia gas and hydrogen chloride gas, again ammonia gas and hydrogen chloride from ammonium chloride. This is shown in this figure. This is shown. When heat applied, ammonium chloride from ammonia and hydrogen chloride gas, again heat resist ammonia and hydrogen chloride from ammonium chloride. Okay, what about the change in energy? What about the energy change? There is no energy change. If a reversible reaction in endothermic in one direction, it is exothermic in the other direction. If the reversible reaction one end is exothermic, other end will be endothermic. The same amount of heat is transferred each time, so there is no change in energy. So in a reversible reaction, if a reversible reaction is endothermic in one direction, other end will be exothermic. The same amount of heat is transferred each time, so there will be no energy change. Okay, dynamic Tajwar, you are making sound come from you, Tajwar. Okay, dynamic equilibrium when system is closed, reactant from product and product again from reactant. At a time reactant rate of the reactant to product are same. At the beginning, we know, what is the name? Okay, this is at the beginning, reactant to product form we know at the beginning of the reaction is very fast or slow. Give my question answer. Unmute. At the beginning of the reaction, rate of the reaction is faster or what? At the beginning of the reaction, what is the rate of the reaction? Give the answer my question. Hello student, are you listening? Huh? Ryan say, give Ryan Khan Abi Fabi say, at the beginning of the reaction, what about the rate of the reaction? At the beginning. Okay, তারপরে লিজেন্ড বিবিসি, এটাকে লিজেন্ড বিবিসি সাউন্ড করলে বের করে দেব। ফাতিমা, তাজওয়ার, তাইবা, মাহফুজা. Okay, what happened at the beginning of the reaction? Reaction is very slow or fast at the beginning of the reaction? What happened at the beginning of the reaction? Reaction is very fast. Okay, at the beginning reaction is very fast, so reactant to product form. I am showing this like nitrogen and hydrogen, nitrogen gas and hydrogen gas. Nitrogen gas and hydrogen gas, 2NH3. This is the reversible reaction from ammonia gas form. Okay, at the beginning, what is the rate of reaction? At the reaction, nitrogen and hydrogen form ammonia. At the beginning, forward reaction is faster. This reaction faster. This or reactant from product. Then product reactant finish. Then product from reactant. Then reactant from product. Then product from reactant. Then reactant from product. Product from reactant. This way reaction occurs at a time. Rate of the this is the forward reaction. Reactant to product, product to reactant, reactant to product, forward reaction. Product to reactant, this is the backward reaction. At a time, rate of forward reaction and backward reaction is equal. Become equal. This is called dynamic equilibrium. We will see the reaction is finished, but the reaction is stopped. You can guess this reaction is stopped, but this reaction is not stopped. This reaction is still running. For this reason, this is called dynamic equilibrium. Okay. In a closed system must be in a closed system. If the system is not closed, reaction will not form equilibrium. This if I form this calcium carbonate form calcium carbonate form calcium oxide and carbon dioxide gas formed this reaction. This is in a closed system. This is equilibrium, remain equilibrium. If I open this system, the carbon dioxide is escape from the system. The reaction become not reversible. This reaction become irreversible. This way will be reaction. Then reaction will be irreversible. This is reversible sign. Then reaction will be irreversible. If open system it will be irreversible, and in closed system it will be internet problem. This, are you listening me? Hello student, is connecting internet, so problem. Are you listening me? Hello student, are you listening me? I think you are not listening. There's problem in internet showing. Look. Okay, now dynamic equilibrium. So dynamic equilibrium must be in a closed system. Dynamic equilibrium occurs when for a reversible reaction, the rate of the forward reaction equal to the rate of the reverse reaction. Since two rates are equal, it looks nothing is happening, but in reality the reaction is continuously occurring at its stable rate. Okay, for this reason this reaction is dynamic equilibrium, when the rate of forward reaction and reverse reaction are equal. Since the two rates are equal, it looks like nothing is happening, but it is reality the reaction is continuously occurring at its stable rate. Okay, a dynamic equilibrium exists on the concentration of the reactant and product become constant. Concentration of reactant and product becomes constant, although there is no net change. Substances are still moving between reactant and product at the same rate. Concentration of the reactant and product become constant, that means same. Concentration of reactant and product become same, although there is no net change. Substances are still moving between reactants and product at the same rate. The system must be closed to prevent any of the components from escaping. The system must be closed. Why? To prevent any of the components from escaping. Like this is considered equilibrium: calcium carbonate from calcium oxide solid and carbon dioxide. If the system were open, the carbon dioxide would escape into the atmosphere and the equilibrium could not be established. Okay, so system must be closed. Idea about La Chatelier principle. This is the scientist's name. He gave a theory on the equilibrium. This is called La Chatelier principle. Scientist's name is La Chatelier. La Chatelier's principle. His rule is his theory. His theory is called La Chatelier principle. Okay, what give idea about La Chatelier? La Chatelier gives idea. When a reversible reaction is in equilibrium, you make a change. If you make a change when the reaction is equilibrium, it will do what it can do oppose that change. When a reversible reaction is equilibrium, again internet connection is unstable. Okay, when a reversible reaction is in equilibrium, if you change any change, like you give temperature, pressure change, concentration, pressure change, concentration change, the reversible reaction, it will do what it can do oppose that change. Reversible reaction will do something, and your change will oppose. Your change will prevent. If you change any, if temperature increase or temperature decrease or concentration increase, concentration decrease, pressure increase, the reaction will do automatically something, and your change will oppose. Your change will prevent. This is the La Chatelier principle. Like this reaction is a equilibrium, like this reaction. Okay, this reaction, like I shouldn't write this. Hydrogen gas. Okay, this is the ammonia formation reaction. Nitrogen and hydrogen gas to react from ammonia. When nitrogen to hydrogen gas react, it is called, these are reactants, these are reactants, these are product. Reactants. Okay, these are reactants. Reactants. This is the product. Products. Okay. When reactant to product form, this reaction is this is reactant to product form. This reaction is forward reaction. This is the forward reaction. Forward reaction. Then here reactant, product to reactant form. This is the backward reaction. backward reaction, or also called it is reverse reaction. Okay, this is also called reverse reaction. This is a backward reaction, and also it is called reverse reaction also. When the reactants is some temperature, any factor changes, like temperature changes, the equilibrium will shift, do something, and change your oppose your change, oppose your change, or prevent your change. Like this reaction, you increase the temperature, the reaction will move left hand side to right hand side, and prevent your change. So equilibrium will remain same, no change will be occur. This is the idea of Le Chatelier's principle. Like you increase temperature, the reaction will move to the this reaction is move, if the temperature is increases for this reaction, the reaction will move to the right to backward reaction, product to reactant form. So shifted reaction automatically and oppose your change, prevent your change. This is about Le Chatelier from the factor that affect chemical equilibrium: concentration, temperature, pressure, and catalyst. So what are the factors that affect the chemical equilibrium? This concentration, temperature, say pressure, catalyst. Say স্ক্রিন দেখা যাচ্ছে না, স্ক্রিন দেখতেছো না তো এতক্ষণ তো বলো না কেন? খুবই বাজে তুমি, আমি স্ক্রিন অতক্ষণ তো শেয়ার করছি না, দেখো। আমি প্রথমে তো জিজ্ঞেস করি আর ইউ ওয়াচিং মাই স্ক্রিন, কতটুকু পর্যন্ত দেখো নাই? এগুলো দেখছো নি? Le Chatelier আইডিয়া কোন জায়গা পর্যন্ত দেখো নাই? এটা দেখছো? এটা এটা দেখছো নি? এটা দেখছো? এটাও দেখছো? দেখছো? দেখো নাই? আচ্ছা, ওকে। এতক্ষণ থেকে আমি এগুলো দেখে যাচ্ছি আর কেউ দেখে নাই। Very bad. What about energy change if a reversible reaction? So this video is recorded already, you can see these things. Okay, I'll do this quickly. If a reversible reaction in endothermic, have you seen this one? Not. Okay, now I am repeat this one. If a reversible reaction is one end is endothermic, another end will be exothermic. Okay, if another one end is exothermic, if like forward reaction is like I show these things, everything here. Forward reaction, look, this is the reactant substance which participate 10 minutes remaining. Okay, if finish 10 minutes, I will take meeting again. Okay, this is the reactant substance which participate in the reactions are reactants, substance which are produce their product. So in this reaction, reactant is nitrogen and hydrogen, and product is ammonia. when reactant to product form, this is the forward reaction. This is the forward reaction. This is the forward reaction. When reactant to when reactant to product form, this reaction is called forward reaction. Forward reaction. Okay. And again, product to reactant form. Product to reactant form. This reaction is called backward reaction or reverse reaction. When product to reactant form, this is backward reaction or reverse reaction or reverse. So you have understood what is forward reaction. When reactant to product form, forward reaction, and when product to reactant form, this is the backward reaction. When the rate of in a dynamic equilibrium, okay, what about energy change? If a reversible reaction is like one reaction is like forward reaction is endothermic, so backward reaction will be exothermic. This is things. In the other hand, the same amount of heat is transferred each time. If the forward reaction is endothermic, backward reaction will be exothermic. If the forward reaction is exothermic, backward reaction will be endothermic. The same amount of heat is transferred each time. Okay, so net energy, the amount of energy will be no change. What about the energy change during the reversible reaction? Energy change will be remain same. Okay, dynamic equilibrium. Dynamic equilibrium in a closed system. For the closed system, have you seen these things? No. Dynamic equilibrium in a closed system. Dynamic equilibrium occur when a forward for a reversible reaction, the rate of the forward reaction equal to the rate of the reverse reaction. Since two rates are equal, it looks like nothing is happening, but in reality the reaction is continuously occurring at a stable rate. So dynamic equilibrium must be in a closed system. For the dynamic equilibrium, system must be closed. In a dynamic equilibrium occurs when the for a reversible reaction, the rate of the forward reaction is equal the rate of the reverse reaction. You can see the reaction is nothing is happening, but in a dynamic equilibrium reaction is still continuously occurring at its stable rate. A dynamic equilibrium exists once the concentration of the reactant and product become constant. Although there is no net change, substances are still moving between reactant and product at the same rate. The system must be closed to prevent any of the components from escaping. The system must be closed to prevent any of the components from escaping. Like this is a consider the equilibrium. In a closed system, this equilibrium established. If the system were open, the carbon dioxide would escape into the atmosphere. The equilibrium couldn't be established. Equilibrium couldn't be established if open. So system must be closed. Idea about Le Chateller principle. Le Chateller scientist he gave a principle about on dynamic equilibrium. In a reaction is reversible reaction. If any reversible reaction is in equilibrium, if you change any factor, the reaction will do what it can do oppose that change. If you change any change, the reaction will do automatically something, and it prevent your change. Either it move left hand side and right hand side, it oppose your change. This is the Le Chateller principle. When a reversible reaction is in equilibrium, it want to remain in equilibrium. If you change any factor, like you increases temperature or decreases temperature, increases concentration of the reactant decreases concentration. If you change any change, the reaction will move from left hand side or right hand side, from left to right or right to left, and it prevent your change. It prevent your change doing this, and it remain equilibrium. This is the Lachatellier principle. Factors that affect the chemical equilibrium: concentration, temperature, pressure, and catalyst. This factor affect the chemical equilibrium. Okay, this is what are the factor: concentration, temperature, pressure, and catalyst. Okay, these things affect the rate of the reaction, catalyst. Okay, change in concentration. Okay, what will happen? Change in concentration. Change in concentration, like, wow, according to the Lachatellier principle, adding additional reactant to a system will shift the equilibrium to the right, towards the side of the product. By the same logic, reducing the concentration of any product, you will shift equilibrium to the right. Okay, look, if you change the concentration, if you increase the change in concentration of the reactant, like here concentration is like is now 50-50 concentration, 50-50. Okay, 50-50. Okay, so it will remain equilibrium, dynamic equilibrium, when the both concentration remain same. But when you change the reactant concentration increases, like it is now 40, here 50. If it is 70, so equilibrium will shift from left to right, because here is a more, here is a less. So reaction will move from left to right, because it has reaction will move from left to right if the concentration of reactant is increases. Okay, if the reaction is remain equilibrium, remain equilibrium, equilibrium here, remain equilibrium. If you decrease the concentration of the product, decrease concentration of the product, this is the decreased concentration of the product. It was 50, now 30. What will happen? Reaction will move which side? Okay, now question, give my question answer. Have you seen which side reaction will move? Reaction moves towards which side? Left hand to right or right to left? I decrease the concentration of the products. Left to right. Yes, left to right, because it is more left to right. Reaction will move left to right. At a time it become 40 and it become 40, then equal. Okay, reaction will move left to right. Okay, so decreasing less than 1 minute remaining. I will take meeting again within 1 minute. Don't go other side. Okay, so concentration change. বলো কি বুঝি নাই? Less than 1. Okay, this the reverse is if add additional product add, which side reaction will move towards? This reaction, if the product added, if you added product, more product added. Like this is a 50-50. If you add product, more product, like product is 70 and reactant is 50. How does what is the direction of the reaction will be? What will be the direction of the reaction? If the product, if added additional product, more product added, from left to right, equilibrium will shift from left to right or right to left? Huh? Right to left. Yes, right to left. Equilibrium will shift right to left. Okay, right to left move. Okay, if I these things again, I remain equilibrium. Like this is 50-50. Okay, if the reactant concentration is decreased, reactant concentration is decreased, so what will be happen? What will happen? The rate of direction of the rate of the reaction. What will be direction? Left to right or right to left? Right to left. This is the right hand side. Right to left. Okay, this is the 50, this 30. The reaction go lower side, the lower concentration. Okay, high concentration and low concentration. This is left to right. Okay, this thing was told here. According this system, the converse is also true. If you add additional product to the system, the equilibrium will shift to the left in order to produce more reactant. If you remove reactant from the system, the equilibrium also be shifted to the left. Now change in concentration. Change in concentration. Change in temperature. Change in temperature. We know a reaction is two type. Exothermic depend on the temperature energy. Reaction is two type: exothermic reaction and endothermic reaction. For exothermic reaction, heat is produced. Therefore, increasing the temperature will shift the equilibrium to the left. If we increase the temperature for a exothermic reaction, increasing the temperature will shift equilibrium to the left, while decreasing temperature will shift the equilibrium to the right. For exothermic reaction, okay, for exothermic reaction, if we increase temperature, equilibrium will shift to the left, and decreasing temperature, equilibrium will shift to the right. This reaction is exothermic reaction. This is exothermic reaction. I know this exothermic reaction. For this reaction, if we increase temperature, the reaction will move from left to right. Reaction will move from left to right. If we increase temperature, for the production of ammonia, reaction will move increase. If temperature increase, temperature increase, the reaction will move from left to right. As a result, production of ammonia decreases. For this reaction, what will do? You will decrease the temperature. If you decrease the temperature, reaction will move. If temperature increase, reaction move from right to left. For exothermic reaction, And for if you temperature increases, if you decrease temperature, like temperature decrease, temperature decrease, temperature decrease, this sign means like you decrease temperature, reaction will move from left to right, from reactant to product. So more ammonia will produce. Lower temperature, if you decrease temperature, more ammonia will produce. So this reaction for exothermic reaction, for the production of ammonia, this is decreasing of temperature is favor for more product. If we temperature increase, the reaction move backward, ammonia to nitrogen form, backward reaction, ammonia production decreases. If we decrease temperature, reactant to product form, more production form. But this reaction is at lower temperature don't occur. So what will you do? It will be discussed in the next class. Okay. For this is the for the exothermic reaction. This is exothermic reaction. If temperature increase, reaction move from right to left. If temperature decrease, reaction move left to right. Temperature, yes. Now I show the endothermic reaction. Can you give an endothermic reaction example? Okay, calcium carbonate breaking. This is a endothermic reaction. Okay, endothermic reaction. Do you know these things? Endothermic reaction. Okay, this is for this reaction. If temperature, this is for exothermic reaction. This is for exothermic reaction. You know these things. What is exothermic, endothermic? I will not discuss today's class. Exothermic reaction. Now I am doing for endothermic reaction. Here I give this another example. And here forward reaction is endothermic. In this reaction, forward reaction endothermic. Backward reaction is exothermic. Endothermic. Forward reaction is endothermic. If I for this reaction, if I increase temperature for this reaction, increase temperature for this reaction. If I increase temperature, okay, for this reaction, if I increase temperature, the reaction will move from here, temperature increase for exothermic reaction. If temperature increase, reaction move from right to left. It will be when temperature increase in endothermic reaction, it will be left to right. Reaction will move from left to right. Okay, this one will be left to right. Calcium carbonate and calcium oxide and carbon dioxide form. Okay, temperature rise and temperature decrease. If temperature decrease, what will happen? Temperature decrease, it will happen from right to left. Okay, reverse this thing. Reverse this happened. Okay, right to left. Okay, if temperature increase for endothermic reaction move from left to right, more product form. So endothermic reaction, more product form if temperature increases, and temperature decreases, product to reactant form, so production decreases. So this is the temperature effect for the exothermic and endothermic reaction, change in temperature. So I have these things discussed. For an exothermic reaction, heat is produced, therefore increasing the temperature will shift the equilibrium to the left, while decreasing the temperature will shift the equilibrium to the right. For endothermic reaction, if we rise temperature on an endothermic reaction, it is essentially like adding more reactant to the system, and therefore by the Larset rate principle the equilibrium will shift to the right. Conversely, lowering the temperature on an endothermic reaction will shift equilibrium to the left, since lowering the temperature in its equilibrium to the removing a reactant. Okay, evaluation. Okay, unmute everyone. আনমিউট করো দেখি সবাই আনমিউট করছো কিনা আনমিউট করো রায়ান ফাবি আনমিউট করো তাইবা মাহফুজা তাজওয়ার ওয়াকিয়া রশিদ এভরিওয়ান শুড আনমিউট মাইক্রোফোন অন করো করছে তাইবা করছে তাজওয়ার ইয়েস ওয়াকিয়া রশিদ আনমিউট করো আনমিউট করো ফাবি আনমিউট করো আমির মোহাম্মদ আমিরুল okay give my question answer. Okay, what is reversible reaction? What is reversible reaction? Hello, what is reversible reaction? The reaction in which reactant form product and again product form reactant, this is called reversible reaction. Again the reaction reversible reaction, the reaction in which reactant form product, again product form reactant, this reaction is called reversible reaction. Reversible reaction signed by equilibrium sign. What do you mean by dynamic equilibrium? In a closed system, when the rate of the forward reaction and backward reaction is equal and it remains constant, this is called dynamic equilibrium. Hey, do you know what are the factors that affect on equilibrium? This is easy question. What are the factors that affect on equilibrium? Temperature, okay, concentration, temperature, concentration, temperature, concentration are more. Okay, catalyst, pressure, temperature, concentration, catalyst. Okay, these are the factors that affect on equilibrium. Okay, thank you for joining the class. Thank you.